but they did put a calculator app on there that is almost identical to the TI.
Is that on self-service for everybody?
It looks like it. It was on mine. It was on hers. So.
Celebrate good times. Come on.
iPad, and you can use it through there. But if you have a separate graphing calculator, that would work best. If you don't have one, no worries. We'll show you how to get it on the iPad.
And submit the review worksheet from the last 2 days.
Okay. And for the last 2 days, we've been working on the review worksheet from 4445. That is 20 points. Everybody that's been turning it in has been getting really, really, really good scores. So please turn yours in. Do not forget about that. And any makeup work, please work on over the weekend, get that into us. So we're going to look at 4-6. Just a quick warm up here. Part A. Haley, what is 6 minus 4? Okay, so you get the absolute value 2. Haley, what is the absolute value 2? 2, good. Sure, whatever you. Yep. And what do we get here? -3 minus 1. Yeah, you got it. -4. What's the absolute value of -4? Very good. Bill, what's 2 minus 8 going to give us? Oh,
You
what's
2 minus
10 going to give us?
8.
Yeah, good. So you get -8. What's the absolute value of -8?
8.
Good. I'm going to have to turn up this volume a little bit. Jason, what's -5 plus 10? Oh, sorry, -5 plus 12.
7.
Good. What is the absolute value of 7?
7.
Good. 7. That might be real loud. Okay, so we're going to look at evaluating absolute value functions. What we want to do is we're going to evaluate each function when x equals 2. So this is, we looked at this before, where you put f of x, it's a function of x, and what you do is you plug it in. So when you see f of 2, what that means is it correlates to, you're going to plug in 2 where x is into the function. Does that make sense how it's written there? So when we plug in 2, what do we get? What should I write down? And what is the absolute value of 2 minus 5? Good. So that's it. So we're just substituting in 2 for the x's. This is called function notation. My brain serves me, right? It's been a while, but yeah. Chapter 2, function notation. Let's look over example B. Haley, what should I write down here? G of 2. Good, so you get the absolute value of 2 plus 8, and then that gives you 2 plus 8, which equals 10. That's it. So I want everybody at home and here in the classroom, work on example 2 on your own. See if you're able to get it. Then we'll go over it real quick. So again, you're going to plug in -3 for example 2.
Is the worksheet posted yet?
This is the notes, the chapter 4 notes. Right. Are you guys from your note packet? This one here, okay?
Yep.
All right, any questions on how to get 8 and 11 for your answers? At home, are we able to do that pretty easily? Okay. So I'm going to do number 3 with you, and I'm going to have you guys do numbers 1 and 2 on your own. So it says to evaluate the absolute value function when x is 1 and when x is -4. So I want to show you how to write that. When x is 1, we'd write that h of 1 is how you'd say that, equals the absolute value of 2 times 1 plus 9. H of 1. And that's going to equal 2 plus 9. And that equals 11, which equals 11. Having the ones with the absolute value looks kind of weird, huh? It's kind of freaky. So that's half of what they want you to do. They also want you to find out when x is -4. So we would just put h of -4. And then we plug in -4 everywhere that we see in x. So we get the absolute value of 2 times -4 plus 9. And that's going to equal the absolute value of -8 plus 9. And I know we all know that 9 minus 8 is 1. So again, we get a 1 with the absolute value. It's a little crooked. And the absolute value of +1 is +1. So take a second for examples 1 and 2. Go ahead and see what you get for So for the first one, it would be f of 1 and f of -4. And the second one, you get g of 1 and g of -4.
A two-part question, 2 things for each question. You can divide it up into boxes, I guess.
Mm-hmm. For these, I know you can do them in your head, but make sure you show your work, okay? Anya, what did you get for f of 1 as your final answer?
F times 1 equals 1 plus 3.
Good. So what did you get for your final answer? So you got 1 plus 3, which equals the absolute value of 4, which is
4.
4. Good. TJ, what did you get for f of -4?
Four, right?
So if you got f of -4, you're going to plug in -4 for x. Three minus 4 gives you?
-1. Or
Yeah.
-4,
You got -1, so your answer is
1.
1. Good. Josh, what did you get for g of 1?
I'm working on that one right now.
Okay. So we can do it together. You get the absolute value of 1 Hey, Josh, what's the absolute value of 1?
1.
What's 1 minus 8?
-7.
You got it. Good. And Michael, what did you get for G of -4?
I didn't get to that one yet.
Okay. Well, we can do it together. What's the absolute value of -4?
+4.
Good. What's +4 minus 8?
-4.
You got it. Are there questions on the function notation? Yeah.
So we'll give everybody a minute to get these 2 problems in their packet. And then we are going to move into the calculator part today. So I'll give everybody a minute, and then if you have a graphing calculator, I would you to take it out. If you don't have a graphing calculator, I'm going to show you where to find it on your iPad, and it'll look identical to the one that I'm going to use as well. But it also looks very similar to the graphing calculator, the TI-84 graphing calculator. So if you're done copying down these problems in the chat feature, can you please give me a thumbs up? Good, thank you. All right, so the next thing that we're going to talk about today is trying to look at what the graph is so that we can see the shape of this absolute value function. So I'm going to take you through this and then we'll kind of work on these couple of questions and we're going to actually graph them on the calculator. So what I need you to do, everybody at home, and if you're in class, you can do the same thing. I need you to go to your self-service. Self-service, it gives you all of the apps that the district has bought for you for the iPad. And there are a ton of apps in here. They're in alphabetical order too, which is also amazing. We are going to find the app that says Graph in Calc. And it is on the right side of my screen. It has a cute little star feature with a swirly in it. So Graph in Calc. Again, this is in alphabetical order. So you need to go to G. You should see Google Sheets, Google Slides, and then Graph in Calc. I need you to hit the install button, and that installs it into your calculator or into your iPad. So install Graph in Calc. 83. So it should install pretty quickly. Haley, yours installed almost immediately. Yeah. So once you have that installed, if you hit the app, it opens up and looks like this is almost identical to the graphing calculator that you may have purchased a couple of years ago, maybe in 8th grade, 9th grade. I was telling the students in class that I bought mine in 1998 when I started college. So you can calculate that Mrs. Kane is old. Nathan, were you able to install it?
Yeah.
Yeah. Anybody at home have questions about getting it to install? Anybody not able to install it on the iPad? So I'm going to go back to the notes. If you have the paper copy of the notes, we're going to look at the first question here. It says graph y equals the absolute value of x on the calculator. And then it says, what does the graph look like? So I'm going to show you exactly how to do that on the graphing calculator. The first thing you need to hit is the y equals button. The y equals button is the first blue button on the left side of your calculator. So it says y equals. Now we are going to get the absolute value equation. Underneath y equals, if you go down to the orange and then the green, and then it says math. I touch the math button and this screen comes up. At the top of that screen, it says math, and then next to it, it says NUM at the very top in that blue bar. And we're going to hit the NUM button. The first thing says ABS. That's absolute value. So I'm going to just touch that ABS. And inside my calculator now, I have absolute value bars. I'm going to stop there. Does anybody need me to go over that again?
Yes.
Okay. So we're at y equals, which is the top blue button on the left side. And if you move underneath that, there's the orange, the green, and then it says math. Very left side, it says MATH underneath the orange and the green. So we're going to hit that. And then at the very top of your screen, there's a blue heading bar. It says cancel, and then math, and then it says NUM. And I'm touching that NUM button. And then I'm hitting number 1. It says ABS in white. So math, NUM, ABS. And now I need to hit the variable X. That variable X is next to the green button on the left. So if you just type in X and then move your arrow so it's outside of X. So now I have the absolute value of X. If you hit the graph button, so Nathan Haley, hit the graph button for me.
Next to the y equals.
Next to y equals, it says graph. Again, this is at the very top of the screen. The blue button says graph. What does the graph look like, Haley? Oops. Oops. And where is yours? Yeah, so this graph looks like a V. If you weren't able to find it in the calculator, that's okay. We're going to go through it a second time. Yeah, you should be, as long as that's off, should be good, Nathan.
There it is. Get Zoom 6 thing,
Mm-hmm.
and I'll give you like your standard view.
I'll get the X's back in a minute for you. All right, so in your notes, going back to those notes, again, if you weren't able to get it, it's okay. Don't fret. Your homework does not require or involve you having to use the calculator. We're going to do a little summary then. The graph looks like a V. I'll draw a little picture here. So absolute value graphs make a V graph. So number 2, this says graph y equals the absolute value of x and y equals 3x in the same window of the calculator. So I'm going to do this for you if you want to try and follow along. I'm going to hit the done button And by hitting done, it takes me back to my calculator. So I went back to y equals and I moved the arrow to y2. So they want us to use a 3. So I'm going to type in a 3. And then I'm going back to the absolute value of x. So now I should have 2 graphs. And I want to see what's the difference between y equals absolute value of x and y equals 3 absolute value of x. And again, if you're at home and you weren't quite sure how to figure this out, it's okay. I have my screen so that you can see it. So now I have the first graph, which was the wider one. And now my second graph is inside of the first graph. And that's the one that has the 3 in front of it. So the question says, what happens when you change the A value? Well, the A value is that 3 that we placed in front of it. So the first equation didn't have a 3, and this equation now has the 3 in front. And we could describe this as the graph getting maybe narrow. You could say it's on the inside, but mathematically, we're going to say the graph is narrow compared to the first graph. So it kind of has gotten squished together a little bit. It's gotten narrow. So the next part says, how do you think the graph of 4 absolute value of x would compare? So I'm going to place one more in my equation, in my calculator.
You think it's going to be narrower or wider?
So what do you think happens if I put a 4 in front instead of a 3?
More narrow or wider? Narrower or?
I believe it is.
Huh.
But more narrow sounds better. But
It does.
I believe on the worksheet it had like our textbook uses narrower. So the textbook people use narrower. Maybe it should be more narrow. We could call our English people that we know.
That's right.
Yeah. So what do you think happens if I put that 4 in front? Is it gonna get skinnier, more narrower, more narrow? Or do you think it would get wider? Let's look. So now my third graph is inside of the other 2. So you can see that that graph is even more narrow than the previous one. So the bigger the number, the more narrow the graph. I think more narrow sounds better.
That's better.
Yeah. So the graph is even more narrow than what the previous one was. So if I had a 5 in front, or 6 in front, or 7 in front, the bigger the number, the more narrow the graph, the bigger the number in front. Questions so far? So we have one more problem that we're going to look at, and then we'll do a quick summary. Number 3 says, what do you think is going to happen if we place a negative number in front of the absolute value? So think about, what did negative numbers do? What do you think a negative number would do to the graph? So I'm going to go to my calculator. I'm going to delete the 2 equations that I had, but I'm keeping that first equation there. What do you think would happen if it was narrow? So if I have a V, what do you think happens if it's negative? Anybody have an idea? Haley, what do you think? Right now my graph looks like this. If I put a negative number in front, what do you think it's going to look like? What'd you say? Not wider. So if it looks like this, it's going to flip downward.
It's opposite of opening up would be opening down.
So it's going to go down. That's what a negative does. So I'm going to type in -2 so we can see what happens. And type an X inside. So a negative number should make it go down. So the 2 makes it narrow, but the negative makes it go down. And you can see that graph. Kind of looks like a funky, not really an X, but the top one was the original. The one on the bottom is the new one with the negative in front. So a negative number makes it go down. So I will say that it flipped down. Or flipped upside down, it flipped down, however you want to say that. Reflected is the math word that we would say. It reflected downward. How do you think the graph of negative 4x would compare? Well, it's still negative, so it's still going to flip down. And the 4 we know makes it more narrow. So a negative, the important thing to remember, a negative makes it flip down. And I'm going to show you this graph. So now I have a negative 4 and the X inside. Hit the wrong button. There we go. And now that graph is inside of the other one that I had drawn. So that negative 4 is bigger than negative 2. So a bigger number actually makes the graph narrow. So the bigger the number, the more narrow the graph. So I know because you might not be in the class, like this is definitely something where it'd be much easier if you were in the class so that we could help you work through that. And unfortunately, not everybody gets to be here today. But we're going to do a little summary. And then this summary is going to tie us right into the homework. And I'm just going to kind of go through this summary with you. So the first thing, the A value is the number in front. So Y equals A is the number in front. And we're going to be changing that A. If A is bigger than 0, we say the graph opens up. So that means, is it positive? Is there a positive number in front? I'll write positive in parentheses. So when A is positive, it opens up. When A is less than 0 means negative. Nathan, what happens with the graph when the number in front is negative? Yeah, it reflects. We could say that it opens down. Reflect is a nice mathematical word, but we can say opens down as well. So if it's positive, it's open up. If it's negative, it opens down. When the number is bigger than 1, so if I had a 2 in front, or a 4 in front, or a 10 in front, it gets narrow. And when the number is between 0 and 1, this means that it's a fraction. A fraction between 0 and 1. It actually gets wide. So my graph is wide if it's a fraction, a 1/2, a 3/4, a 2/3. It gets narrow if it's a big number, 7, 8, 9, 2, 3, 4. Those are all the notes that we are going to do today. I want to start the homework with you so that you can see that you don't need a calculator to do the homework. The homework actually relies on these 4 pieces of information. That's what the homework is going to rely on. So I want to make sure we have that written down in the homework as well. So if you want to go to Google Classroom, the worksheet should have posted. Oops. It should say practice 4.6 worksheet. There are 6 questions where you're going to evaluate. That's what Mr. King did with you. You plug the number in for X. So why don't we just start number 1 together? I made it a cute little T-chart so that you could kind of organize yourself. But they're telling you X is equal to -4. That's the number you're plugging in for X. Haley, were you able to find this on Google Classroom? Yes, okay. So I have absolute value, -4 minus 4. That's what I'm doing on the left side here. I'm plugging in a -4, which is really -8. Haley, what is the absolute value of -8? 8. So that's all I have to do on the left side. And then on the right side, you're plugging in a -5. So -5 minus 4. Michael, what is -5 minus 4? Nathan, can you help him out? Do you know what -5 minus 4 is? -9, and the absolute value of -9 is 9. So that's what you're doing for the first 6 problems. You're plugging the number in. I made it a little T-chart just so you could organize yourself. So plugging in the -4 on the left, plugging in a -5 on the right. It's the same 2 numbers every single time. And then down below, it says, tell whether the graph opens up or down. I'm going to write positive for up, negative for down. So if it's positive, you're writing up. If it's negative, you're writing it opens down. Then tell whether the graph is wider. Well, wider is a fraction between 0 and 1. Narrower should be a number bigger than 1. So if I look at number 7, there's 2 things. Does it open up or down? Well, it's negative. So Nathan, if it's negative, does it open up or down? Down. So this opens down. The second part is the 12. Is 12 bigger than 1 or between 0 and 1? It's way bigger than 1. 12 is way bigger than 1. So this graph is narrow. Narrower. So your homework is to finish this worksheet. Those last 6 problems hopefully would be pretty straightforward. You're just writing 2 different statements for them. Have a fantastic weekend, and we'll see everybody in Group A on Monday. It is the weekend. How about that? Have a good weekend.